In general, most machine learning techniques can be classified into supervised learning and unsupervised learning. In supervised machine learning, the algorithm is provided an input data set and then is rewarded or optimized to meet a set of specific outputs. For example, supervised machine learning is widely deployed in image recognition, which was mentioned earlier, and it utilizes a technique called classification. Compared to unsupervised machine learning, the algorithm is provided an input data set, but not rewarded or optimized to specific outputs, and instead trained to a group of objects by common characteristics. One example could be recommendation systems or recommendation engines, also mentioned earlier. And this is typically done using a technique called clustering. But we can expand on this a little bit further, but I think it's first important to discuss the differences between models and algorithms, because I have used both terms quite frequently in the last 15 minutes in itself. An algorithm is an algorithm in machine learning is a procedure that is run on data to correct a machine learning model. Machine learning algorithms are procedures that are implemented in code and are run on data. Machine learning models, on the other hand, are outputs by algorithms and are comprised of model data and prediction algorithms. So algorithms typically tend to come before the model. Moreover, a machine learning model is a program that can find patterns or make decisions from previously unseen data. So again, for example, in image recognition, a machine learning model can be taught to recognize objects, whether this be cars or dogs, and then the machine learning model can perform such tasks by having it trained with a large data set. During this training, the machine learning algorithm is optimized to find certain patterns or outputs from the data set, depending on the task. The output of this process the output of this process is named a machine learning model. So how exactly does a machine learning algorithm work? There are three really important functions to a machine learning algorithm. The first step is the decision process. This is the steps that take in the data and guess what kind of patterns your algorithm is looking to find. In general, machine learning algorithms, as discussed, are used to make predictions or classifications. So based on some input data, which can be labeled or unlabeled, your algorithm will produce an estimate about a pattern in the data. The second function to a machine learning algorithm is the loss/error function. So this measures how good the guess was by comparing it to other examples. An error function basically serves to evaluate the prediction of the model. So if there are known examples, an error function can make a comparison to assess the accuracy of the model. The last function is the model optimization process. And this is simply a method in which the algorithm looks at the miss or the error and then updates the decision process. So basically, if the model can fit better to the data points in the training set, then weights are adjusted to reduce the discrepancy between the known examples and the model estimates. This algorithm will repeat itself and repeat the evaluation and the optimization process until an accurate threshold has been met. Just a little bit more about models and their implications. Learning models are established based on data-driven principles. So a typical process is to learn / discover generic patterns based on a training data set. And it's important to know that machine learning works in an inductive learning manner. In an inductive learning manner. This means that it learns / discovers a generic rule from a number of examples generated by such a rule. And the nature of machine learning always limits the training data to only a specific sample of a population to be modeled. The most important fact here to know is that the ultimate goal of machine learning is towards inductive bias or generalization. So a learning model can predict output correctly given input that have not been encountered during learning. In other words, a learning model should be able to generalize the rule learned from observed data to the unseen data. So we can move on now to discuss the differences between supervised learning and unsupervised learning a little bit better. So what is supervised learning? Well, we can understand what this means by looking directly at the words that make it up. Supervised means to observe and direct the execution of a task or an activity. And using this definition, we will be supervising a machine learning model that might be able to produce classifications. But how do we supervise a machine learning model? We do this by teaching the model. We load the model with knowledge and then have it predict future instances. So how do we teach this model? In short, we can teach a model by training it with a labeled dataset. Supervised machine learning algorithms functions with data that is already labeled. Each sample is typically tagged with one or like several labels according to the category of objects. It then corresponds to specific characteristics and properties which allow the identification and classification of objects. Now, according to the labeled data, the system is learning from, it will be able to use this piece of information to identify and classify new images. The example on the slide is from a dataset called IRIS, which is, you may or may not be familiar with, but it's a very, very common dataset used for machine learning and statistics. So there's another overlap. But I think it's important just to talk about some of the components because there are overlaps in the names of these variables. So if you look at the rows, we have the sepal length, the sepal width, the petal length, the petal width, and the class. So these names are its attributes. These are also known as its variables. However, if we look down the columns, that this includes the data and are typically known as features. These are also known as your values. Well, I thought it was just useful just to provide a bit of context to the overlaps in names. So there are two types of supervised learning. We have regression and classification. Now, a regression algorithm can predict a discrete value, which is in the form of an integer, whereas a classification algorithm can predict a continuous value if it is in the form of a class label. So classification in itself is a predictive model that approximates a mapping function from input variables to identify discrete output variables, which can be labels or categories. So an example from the IRIS dataset might be that you're attempting to predict class against, for example, sepal width. Compared to regression, now regression algorithms tend to predict a continuous value based on the input variables. The main goal of regression problem is to estimate a mapping function based on the input and output variables. So yeah, if your target variable is a quantity like income, scores, height, or width, or if the probability of a binary character, then you should use a regression model. Here are some supervised algorithm examples followed in the classification and regression. In classification, some examples of the algorithms include a decision tree, random forecast, or a k-nearest neighbor. A decision tree is, in this algorithm, a classification model basically is created by building a decision tree where every node of the tree is a test case for an attribute, and each branch coming from the node is a possible value for that attribute. We then have random forest, so this is a little bit different. And this is a tree-based algorithm, and it includes a set of decision trees which are randomly selected from a subset of the main training set. We then have k-nearest neighbor, which is another example of an algorithm in the supervised learning. And this basically assumes that similar things exist in close proximity to each other. We then have some example algorithms from regression. So this includes simple, multiple, and polynomial regression. Typically, this is where we estimate the relationship between one independent variable and another dependent variable, or multiple dependent variables if you're using multiple linear regression. But yeah, these are just some examples of algorithms in the supervised learning. These do not include all possible algorithms. So now we can move on to understanding what is unsupervised learning. In short, we do not supervise the model, but instead let the model work on its own to discover information that may not be visible. Unsupervised learning uses machine learning algorithms that draw conclusions on unlabeled dataset. So this is the opposite to supervised that uses labeled. Unsupervised learning is said to be more complex because we have little to no information about the data or the outcomes to be expected. Unsupervised learning has fewer tests and fewer models that can be used to make sure the outcome of the model is accurate. Therefore, we have less of a controllable output. Compared to supervised learning, unsupervised classification or clustering algorithms attempt to discover structure in data by organizing into groups whose members are similar to each other. The raw dataset being used in the unlabeled, and then the algorithm identifies the patterns and relationships within the data without help from the user. Here in unsupervised learning, there are three subfields, that is clustering, association, and dimensionality reduction. Now, clustering involves the analysis of patterns and groupings of unlabeled data, as previously discussed. We then have an association. So an association rule is basically it's a rule-based method for finding relationships between variables in a given data set. So these methods are frequently used for market analysis, and they allow for companies to better understand the relationships between different products, for example. And then we have dimensionality reduction, and it is a technique used when the number of features or dimensions in a given data set is too high. So it reduces the number of data inputs to a manageable size, while also preserving the integrity of the data sets as much as possible. It's typically commonly used in pre-processing data stage, and there are a few different dimensionality reduction methods that can be used, as seen on the screen. But we're not going to discuss too much about these algorithms, as they can be a little bit complicated, but we'll be discussing some of these in the later sessions this week and next week. Just for some reference, there are also some other machine learning methods that move from supervised and unsupervised. So we have semi-supervised learning, reinforcement learning, and deep learning methods. Semi-supervised learning refers to a learning problem that involves a small portion of labeled examples and a large number of unlabeled examples from which a model must learn and make predictions. So it kind of falls between the two. We then have reinforcement learning, and this happens when the algorithm interacts continually with the environment rather than relying on training data. One of the most popular examples of reinforcement learning would be autonomous driving. We then have deep learning, which was briefly discussed, but this is a newer area of machine learning that automatically learns from data sets without introducing human rules or knowledge. So this requires massive amounts of raw data for processing, and the more data that is received, the more the predictive model improves. But as of recent, supervised and unsupervised learning methods make up a lot of the